Hey there, StudyBuds! This is your StudyBud Isabel. Do you know that the world, the entire universe rather, is made up of two things? Yes, they're matter and energy. For today's trip to StudyWorld, we will be taking a trip to the world of chemistry, the branch of science that deals with matter. That's our topic for today. Matter, in its simplest definition, is anything that has mass and occupies space. But if you want to know more about matter, including its particulate nature, states, physical and chemical properties, extensive and intensive properties, ways of classification, then please keep on watching. By the end of this video, you will be able to know matter beyond its particulate nature of matter. Matter is particulate in nature. This means that between separate fragments of matter, there are also spaces which contain no matter. This is the atomic nature of matter, which was proposed by the Greek philosopher Leucippus and his student Democritus. This is bounded by the atomic theory that gave rise to the now common knowledge that there are many particles which make up matter. The primary particle in chemistry is what we call an atom. It was thought to be the most indivisible particle. However, it was later found out that it had three subparticles: protons, neutrons, and electrons. As far as we know, there are three types of particles with no further subparticles: quarks, electrons, and neutrinos. But maybe someday we'll get to discover more. Not just more particles of matter, but also its state. As of now, we know that there are three states of matter in our planet, while there are two states found in extreme temperatures. The three states of matter are solid, liquid, and gas. Solid has both definite shape and volume. This means that the container makes no difference, and that's the case for solids. Gas has both indefinite shape and volume, which means matter takes on the shape of the container and expands to fill the entire container. Liquids are in between. They have indefinite shape and definite volume. The other two states of matter found in extreme temperatures are plasma and Bose-Einstein condensate. Plasma is created at several million degrees Celsius, while Bose-Einstein condensates exist only at very low temperatures, almost close to absolute zero. They are both useful, but only to physics. We'll know more about these two in another trip. Physical and chemical properties. The two useful things about matter are its physical and chemical properties. Physical properties can be observed or measured without changing its space or form, or chemical reactions that produce new compounds. These properties include color, molecular weight, and change of state and volume. Physical changes happen in crumpling a paper, melting ice, or breaking a bottle. On the other hand, chemical properties may only be observed by changing the chemical identity of a substance, which measures the potential for chemical change. Examples include reactivity, flammability, and oxidation states. Chemical changes happen in burning wood, mixing base and acid, and rusting. Extensive and intensive properties. The physical properties of matter are further classified into two: the extensive and the intensive properties. This is according to how the property changes when the size of the system changes. On a more in-depth discussion, extensive properties depend on the amount of matter being measured. The extensive properties scale directly with size. Say, if the size of a system doubles, the value of an extensive property doubles as well. These properties must exhibit an additive property when changing the amount of substance. Let's take a 2.2 kilogram mass of uncut diamond as an example. If 0.7 kilograms of this diamond is cut away, we will be left with 1.5 kilograms of diamond. This means that the cut away piece and the remaining piece must add up to the original mass. Some examples of extensive properties are energy, length, mass, size, volume, and weight. On the other hand, intensive properties do not change as the amount or size of the substance changes. These properties are used for sample identification because they are the same for all sample sizes. Some of these intensive properties are boiling point, melting point, freezing point, density, color, temperature, and pressure. Take freezing point as an example. If the freezing point of a liter of water is 273 Kelvin, 4 liters of water would have the same freezing point, since freezing point is an example of an intensive property. It does not change no matter how big the amount of substance is. The easiest way to tell extensive and intensive properties apart is to take two samples of the same type of matter and combine them. A physical property would be considered an extensive property if the extensive property doubles along with the sample size. If the physical property remains the same, then it is an intensive property of matter. In general, all of the basic properties we think about using to describe a system, mass, volume, density, pressure, temperature, viscosity, color, etc., can be divided into these two categories. Ways of classifying matter. Since we are now familiar with the properties of matter, let's move on to classifying them. Chemists have found that all forms of matter may be divided into two general groups on the basis of their properties. These are pure substance and mixture. Pure substances. Generally, pure substances have uniform chemical compositions. So, when we speak of pure substance, we are talking about something that contains only one kind of matter. This can either be one single element or one single compound. But every sample of the substance that you examine must contain exactly the same thing with a fixed, definite set of properties. Pure substances are further broken down into elements and compounds. Elements. An element is a substance that cannot be broken into other substances by ordinary means. It consists of only one kind of atom. These elements are what we usually see in our periodic table of elements. And as of 2016, the periodic table of elements has 118 confirmed elements. Fun fact, one of the most fascinating facts of science is that all matter is composed of about 112 elements. Isn't that amazing? Approximately 90 elements are known to occur in a free or combined state in the Earth's crust in detectable amounts. A compound is a substance formed when two or more elements are chemically joined. If a substance can be decomposed into two or more simpler substances by ordinary chemical means, it is a compound. Say water, for example. We all know that water is H2O, and chemists are able to decompose water into two simpler substances, which are hydrogen and oxygen. These two are elements. Therefore, water is an example of a compound. Since the properties of compound and elements are uniform, they are classified as substances. Mixture. When two substances are mixed together, the result is now what we call a mixture. A mixture is a material consisting of two or more kinds of matter, each retaining its own characteristic properties. Hence, the properties of a mixture are the properties of its ingredient. They are those physically combined structures that can be separated into their original component. Another fun fact, there are three kinds of mixture. These are solutions, which are homogeneous, suspensions, which are heterogeneous, and colloidal mixtures, which may not be clearly homogeneous or heterogeneous. But with this, we will only be classifying mixture into two categories: homogeneous and heterogeneous. A homogeneous mixture, which is sometimes called a solution, is relatively uniform in composition. Every portion of the mixture is like every other portion. For example, if you dissolve sugar in water and mix it very well, your mixture is basically the same no matter where you sample it. On the other hand, a heterogeneous mixture is a non-uniform mixture in which the components separate and the composition varies. A material which shows different properties such as color and size of component is said to be heterogeneous. Unlike the homogeneous mixture, heterogeneous mixtures can be separated through physical processes. Heterogeneous materials are actually a mixture of homogeneous materials. Heterogeneous mixtures involving at least one fluid are also called suspension mixtures and separate if they're standing long enough. Suppose we mix oil and water together. Regardless the amount of time spent shaking the two together, the water and oil will eventually separate with the oil rising to the top and water below, because water is denser than oil. But there are mixtures that can be classified between a solution and a heterogeneous mixture. They are called colloidal suspensions, or just colloids. They do not spontaneously separate nor settle out as time passes and cannot be completely separated by filtering through a typical filter paper. Methods of separating mixtures into their component substances. Since most substances are naturally found as mixtures, they can be separated into their natural components. So finally, we will tackle the methods of separating mixtures into their component substances. Separation is usually done to remove all unwanted materials and obtain useful components. These are several types of separating techniques that are used in segregating a mixture of substances. Handpicking. This method involves simply picking out all the unwanted substances by hand and separating them from useful ones, or maybe both the separated substances are useful. Sieving. Used in separating mixtures that contain substances mostly of different sizes. The mixture passes through the pores of the sieve, hence, all the smaller substances pass through easily while the bigger components of the mixture are retained. Evaporation. In this method, the solution is heated until the solvent evaporates where it turns into gas and mostly leaves behind the solid residue, usually used in separating a mixture of solvent and soluble solid. Distillation, a method used to separate two or more pure liquids. The components of a liquid mixture are vaporized, condensed, and then isolated. The mixture is heated and the component which is volatile vaporizes first. The vapor moves through the condenser and is collected in a liquid state. The condensate that is collected is called distillate. Filtration, most common method of separating a liquid from an insoluble solid. Filtration is used here to remove solid particles from the liquid. Various filter materials are normally used in filtering. Sedimentation, process by which heavier impurities present in liquid, normally water, settles down at the bottom of the container containing the mixture. Magnetic separation, separating components of mixtures by using magnets to attract magnetic materials. Matter is everything around you, and what's fascinating about it is that you can determine its presence through the use of measurements. But how do you measure matter? That's what we will be talking about on our next trip to StudyWorld. This has been your StudyBud Isabel, telling you to never stop learning. Till next time, StudyBuds!